In part 2 of Chapter 10, Energy Sources, we're going to talk about different kinds of nuclear energy, sources, advantages, and disadvantages. Okay, the most common source of nuclear energy used today by humans is nuclear fission. Fission means to break apart, and that's exactly what happens in nuclear fission. The nuclei, the inside, dense part of atoms where neutrons and protons live, they are split apart in nuclear fission. And from one point of view, really what it is a conversion of some mass into energy. Just as a reminder, this equation here, discovered by Einstein, reminds us that there is a connection between mass and energy, and that's exactly what happens in nuclear fission. A tiny, tiny, tiny little bit of mass is converted to energy. From another point of view, it could be said that nuclear potential energy is stored in the nucleus of some atoms, and that we can use the process of nuclear fission to turn that nuclear potential energy into heat energy, and then into kinetic energy of a moving turbine, and finally into electricity, in a very similar way to what happened with fossil fuels in a power plant. Inside a nuclear fission reactor, there are three main elements that are common. One is some source of fuel. This is usually an isotope of uranium, U-235, but it can also be plutonium. There's also going to be what's called control rods. These control rods slow down the process of nuclear fission so that it's controlled and useful and not dangerous. And they do this by absorbing neutrons. And then finally, there has to be some sort of cooling system. If you've seen a big tower and a big cloud of smoke coming out of it, and someone said that's a nuclear reactor, really what you're seeing, that big tower with the smoke coming out of it, that's the cooling tower. That's where excess heat is removed from the system so that the system is not damaged. This little cartoon down here helps us to get an idea of how nuclear fission happens. In my drawings, the black marbles are supposed to be neutrons and the red ones are protons. So what happens in a typical nuclear fission situation is that a neutron is projected at a big heavy nucleus. This big ball here is a nucleus of some heavy atom like uranium or plutonium. If this neutron is traveling fast enough, it can cause this heavy nucleus to break into two lighter nuclei, here and here. Also, there's going to be neutrons released, and these neutrons are going to go on and hit other nuclei of other heavy atoms and cause this process to continue. In the process of breaking apart this nucleus, energy is released, and of course that was the whole point. So as these two neutrons here and here spread out, this process is going to accelerate, and that's what we call a chain reaction. And what the control rods do is they'll absorb some of these extra neutrons so that the reaction doesn't accelerate too much. The control rods are they're raised and lowered in and out of the core where the reactions are taking place to speed up or slow down the reactions. If there were no control rods, the reaction could get out of control and the whole nuclear power plant could explode. So they're a very important part of the system. Alright, so one key advantage to using nuclear energy as opposed to burning fossil fuels is that there's much less air pollution and there's no carbon dioxide released in this process. This is very important. But there's several disadvantages as well. Nuclear fission uses uranium, which is a non-renewable resource. There's not going to be more uranium made in millions of years. There's just never going to be any more made. What we find in the ground is all there is. And also, the use of nuclear energy results in some very nasty and dangerous radioactive waste products. And handling and storing these waste products is a challenge. If there should be a lack in security and these materials are stolen, they could be used to make weapons. If people just don't pay enough attention and don't store these things properly, this radioactive waste could pollute the environment and hurt a lot of people, plants, and animals. There's another kind of nuclear energy that is not used today on Earth in any way except in a pure research sort of way, and that is nuclear fusion. Fusion means to join together, as compared to fission, which means to split apart. In nuclear fusion, we're going to take the nucleus of one atom and the nucleus of another and fuse them together, join them together into a bigger nucleus. Okay, so fission took a big nucleus and made it into two smaller ones, and fusion takes two small nuclei and makes them into one bigger one. And this is the sun's secret. This is how the sun shines. The sun makes energy and light and heat by fusing hydrogen into helium. And it could be a future solution to all of our energy problems. If we can master the process of nuclear fusion, it could be a great thing for our civilization. It doesn't produce much dangerous waste, and it produces a lot of energy. So the problem is that so far we have not figured out how to make nuclear fusion happen in a practical way, in a self-sustaining way, in a way that we could use to create electricity. So here's a little cartoon of what nuclear fusion looks like. Two different kinds of hydrogen come together, H2, or deuterium, and H3, or tritium, and in the process, if they're moving fast enough, they can fuse to create helium, helium-4. Another neutron will be produced by this, and high-moving neutrons are a dangerous aspect to the process of nuclear fusion, and lots of energy will be created. So that's the process in a very simple way, and the problem is that it's hard to maintain the temperatures and pressures that are needed to make this process continue. The sun can do it because it's huge and hot, but it's a lot harder for us to figure out how to do that. So why don't you give the book a chance to teach you? Read through section 10.2, please, and when you get to the end, on page 304, have a shot at questions 1 through 4. Alright, I'll see you in part 3.